All right, I want you to open your workbooks to page 66. And what we're going to do in this is we're going to work through the problems on this page together. We've talked about similar shapes, similar figures a little bit previously, so a little bit of this will be a review for you, but I'm going to add one more little piece of new information that's really very simple. When we talked about similar figures before, we looked at the lengths of the sides and if they were related to each other. Because we know that similar, in order for two shapes to be similar, and if you don't remember this, you may want to write this up at the top of your paper. But in order for them to be similar, they have to be the same shape, but different size. Now, when they're different sizes, they are going to be proportional. Okay, so they can't just be totally different sizes with no kind of relation between them. Okay, so what we're going to look at on this page, we don't have the lengths of any side of these, triangles. All they give you are the angles. So I want you to make a note, kind of over here on the side or maybe up here at the top if you have more room. But if triangles have two angles congruent, then that has to mean that the third angles are congruent and the triangles are similar. Because if all three angles are the same on both triangles, then your triangles will be similar. The lengths of the sides don't have to be the same, but they will be proportional. So take a second, pause the video if you need to get that written down, and then we're going to look at the examples here. Okay, so example 1, okay, I automatically noticed right off the bat that both of them have an angle that's 122 degrees. But then on this bigger one, I notice an angle is 30 degrees. The other one I notice is 28. And then we are missing an angle on each of them. Okay, so what you need to do is figure out what either x or y is. If y is equal to 28, then they're going to be similar because that means x would have to be 30. And same thing vice versa. If you figure out that x is 30, then they're similar. Y would have to be 28. So remember, the angles inside of a triangle have to add up to 180. So I'm going to work on this bigger triangle first. 122 plus 30 is 152. And 180 minus 152 is 28. So that means that angle Y right here is 28, and that is the exact same thing as what's over here. So are these two triangles similar? We're going to say yes, because all angles are congruent. Okay, let's look at number 2. I have y, 52, and 40. I have 86, x, and 40. So I know they share a 40. So if I find that y equals 86, then they will be similar. So let's figure this out here. 52 plus 40 is equal to 92. And I take 180 minus 92, because I know that angles have to add up to 180. And you get 88. So on this one, it's 88, but over here, it's 86. So they're close, but they are not exactly the same. So these two triangles, no, they are not similar because y equaled 88 degrees, and that does not equal 86. They would have to be the same for them to be similar. Okay, I'm going to erase this so I can scroll down, so pause if you need to. Number 3. Okay, again, I see they share a 20-degree angle. So if I find that, let's say, x is 105, then they will be similar. So let's see here. We have 65 plus 20. You get 85. Subtract that from 180. And you get 95. So x is 95, and that does not equal 105. So no, these are not similar because x equals 95 degrees, not 105 degrees. Okay, and then number 4, again, I notice they have a 90-degree angle in common. So I need to figure out either x or y and see if it matches up with the other. So let's work right here on this right triangle, or I guess the triangle on the right. We have 90 plus 55. You get 145. Subtract that from 180. That should be 35. Sorry. So x is 35, and yes, that matches up with that angle. So yes, these are similar triangles because x equals 35. So all angles are congruent. So what we were looking for on all of these examples in 2 triangles, if all 3 angles match up with each other, if they're the same measures, then your 2 triangles will be similar. And in a triangle, if 2 of the angles are the same, then automatically all 3 have to be the same. Okay, now let's look at number 5. It says you can use similar triangles to find the height of a tree. It says triangle ABC, which is the bigger one, is similar to triangle DEF. So we just learned that because they're similar, all of their corresponding angles are equal to each other. So just real quick, this angle A right here would be equal to this angle D right there. Angle B and angle E, they already show you that they're the same because of the right angle. And then angle C is the same on both of them. So what we do to figure out the height of the tree, and I want you to write this note over here, we have to set up a proportion, which we did this quite a bit whenever we talked about similar figures before. So remember, a proportion is 2 fractions that are equal to each other. Okay, and I told you that if you use one shape as the first fraction and the second shape as your second fraction, that'll set up your proportion really nicely. So I have 2 triangles that I'm comparing here. I have ABC, which is the bigger one, and I have DEC, which is the smaller one. Now I drew these out separately because it's easier for me to see, it makes it more visual. And I'm going to label the lengths of the sides that I know. So on ABC, I know that AB right here, this is X. That's what I'm trying to figure out. Now the length of BC, that is this entire piece down here. Notice that that covers 9 plus the 6, which would be 15. Okay? And then on the small triangle DEC, I notice that DE is 4 feet, right there, and EC is 6 feet. So these are the numbers that I'm going to pull into my proportion. So have the big triangle be one fraction, so x over 15, and have the little triangle be the other fraction. Now, since I put the x as the numerator, what corresponds with the x over here? That would be the 4, so it has to be the numerator. And then the denominator would be 6. Now to solve a proportion, you guys know we cross multiply, so x times 6 is 6x, and 15 times 4 is 60, and then we solve this. Divide by 6 on both sides, so x equals 10. So the height of that tree that we just found out is 10 feet. So we can use similar triangles to figure out a missing height just by setting up a proportion.